Hello statistics student, this video is for chapter 5.1 continuous random variable. As we have covered in chapter 4, a random variable is a variable x, we usually call x, that is a value determined by chance. And for discrete random variable covered in chapter 4, those numbers are discrete number or counts. Now we're running into when x is actually a continuous data. It can take on any values between two numbers. An example would be you pick a student and get the height from the student. Now the height's values is continuous. It can add in number between two numbers. So the probability of x or the range of x is cannot be determined by a table, but rather it will be determined by a function called the probability density function, or in the short form, we call it the density curve, f of x. But unlike a function that we use in algebra, when we plug in something into a function, we get a number. Yes, we do. But to find probability, we do not plug in to get the number. We will graph the density curve, and then the area represents probability. So how do you find area? When you plug in an x, you only get a value of f of x, right? So to find area, strictly speaking, you use calculus integration. But in this algebra-based statistic class, we're going to use an online calculator to find area. So remember, to find area of a random variable x, so x is here. These are all the different value of x. You would look at the range of x that you want, and you find the area under the curve. So this would give us the probability. Then you might ask, Ms. Chen, I just want to find probability of x equal to something. Is it necessary? No, it's not necessary. In the case of x being a random variable, probability of x equal to a value like a or any number or b or c is always equal to 0 because it's continuous. So there's no area at a point. Right? A point is just a line, there is no area. An area has to be a range of x value, but rather you would have a range of x. Now this range of x can be like this. You can have x is between two number, a, b. This is the notation of x between two number. You can have x is greater than a number, greater than b, or you can have x is less than b. So it could be a greater than area, one-sided area, or, the left side, right side, or the middle area. Anyway, area represents probability, and x equal to a doesn't represent anything. It's always 0. So when we find probability, we use the density function to find the area. We use the density function to cover an area. And because it's a density function, it's a probability density function, the total area covered by this function is always 100%, because these are all possible values. In case you have x being able to take on all possible value from negative infinity into infinity, it's possible to define the density function that goes on forever, but the total area is still equal to 1. So see, if I shade the all area from the valid range from 0 to whatever the maximum x can take, it should be 1. And also this graph is always above the x-axis. So the properties of a density function is probability of a range of x. We always talk about a range of x. So when we say probability is a range of x, not x equal to a number. Is equal to area under the curve, and it's also equal to percentage, because probability is relative frequency, which is percent. So there's two important continuous probability function. One is a uniform distribution. So for uniform distribution, I have graphed it here. Oh, did I? Oh, yeah, below. So the density function is just a horizontal line that covers from the lowest and highest value of x. So there is a lowest value. So in this case, it's from 2 to like 8 point something. So this is the density function, and the area under the density function represent probability. Okay. Oh, it is 8.8. So probability that x is between 3 and 6 would be you find the area between 3 and 6. So in this course, I'm not going to calculate these. These are pretty straightforward. But basically, find the area. You don't need to look up table. You just need to use geometry. It's a rectangle, so length and width. Usually the height is given to you, or you can figure out what height is because the total area is under 1. Under the area is 1. The second one that I want to introduce, the famous density function, is normal distribution. So it's a normal bell curve. So this bell curve represents a symmetric bell-shaped kind of distribution of x. So if x has most of the data clustered around the middle, symmetrical on both sides, we say it is called a normal distribution. Symmetrical bell shape is also known as normal distribution. Normal is a jargon word. So again, if I want to find the probability of x is between a and b, I would just highlight a and b on the x-axis because it's x between, under the area for x equal to b. Yeah, between a and b is the area under between x equal to a and x equal to b. So how do I find this? This would be found by using an online calculator. If you search online, normal calculators, there are tons of them. And I particularly use one from OpenStax textbook. So for example, if I want to find the shaded area is, or the x is less than a, right? So there's a small a here. So the shaded area is probability that x is less than a. And in a symbolic form, we can say probability x is less than a. And this one is, these x are all greater than a, right? So if you shade the number line, so it would be probability of x is greater than a. Earlier, the one that we have in between, let's write it down. So I want you to also be able to do those notation. The number line, the number sentence notation is x is between a and b. We always use this less than, not greater than. Okay, so that is okay, the last part. So the notation, yeah, we have the notation here. So probability of x is between a and b. Oh, I'm ahead of myself. I actually talk about notation. Is probability of a is between a and b, or a is greater than equal to a, greater than equal to b. X is a is less than equal to x is less than equal to b. But whether you have an equal or not doesn't matter because probability of x equal to a is 0. So you can use either one. In algebra, these two are different, right? But in statistics, they are the same. So some software use the greater than equal to, some software use just greater than or less than. And notice that probability of x equal to any a is 0. Okay, so these are the properties and also the notation of how we use a area under the density function to represent probability.